Good evening, and welcome to Kopernik Observatory. For those that don't know, my name is Drew Desker. I'm the director here. I want to welcome everybody here at Kopernik, as well as those watching on the live stream for our program this evening on the history of Planet X. Tonight's sort of a rare night in that I almost recognize every face in here, which is great. So it's nice to have some return customers, and we're very fortunate this evening. Actually, earlier this week we were looking at the forecast for the skies, and it did not look promising. And even as early as 4 or 5 hours ago, it looked even less promising. But we've actually had an opportunity to take a look at the moon, and we've actually got a scope out there now that we'll start doing this a little more often. That actually has a cell phone adapter attached to it. And so afterwards, presuming that the skies remain clear, if you're interested, we can put your cell phone on that scope. We'll dial it in, and you can get a really great picture of the moon this evening through one of our scopes. So let's see here. I'll talk a little bit about our website here. Website always keeps you on top of what's going on. So tonight, our topic is the history of Planet X, which we'll get to in a few moments. One of the things also that people don't necessarily realize is that the Kopernik Observatory was started by the Kopernik Society of Broome County. It's a group of Polish immigrants, people of Polish heritage here in the Southern Tier. And a part of our bylaws and our Constitution indicate that what's written into that is that we also are promoting Polish heritage. So actually tomorrow, Sunday afternoon, we're having a Polish picnic. We did ask for some pre-registrations, but I think we still have room for, so any of you out there that might be interested, show up at 1 o'clock and on Sunday and come join in celebrating our heritage here. Well, one of the things that Kopernik does is, besides doing a lot of school outreach, which we've been doing pretty much the entire school year here, is during the summer we offer STEM-themed summer camps for students going into second grade through high school. And so you can actually learn more about this by clicking on this link. It takes you to another portion of, actually that's the, let me go back here one. All right. Read more. That's where I wanted to go. So you can go to this tab up here and learn about the camps. A number of them have already filled up. And yeah, here it is. So actually, the super scientist just filled up. We've got a number of other camps that still have some room in there. One of which is actually one that I do called Return to the Edge of Space. These are middle and high school students that will build a payload that will fly on a weather balloon up to over 100,000 feet. We have some science experiments. Actually, this year we'll be flying a Geiger counter to see what kind of, as you get higher and higher in altitude, the exposure to cosmic rays increases. In fact, actually, I took the Geiger counter on a flight last week, actually, and noticed a notable increase in cosmic ray exposure, even at 30,000 feet. Well, these balloons will go up to over 100,000 feet, so we'll be tracking that. So anyway, going back to our website here, you can always find out what's going on. One of the things that's happening tomorrow, and we are actually essentially full, is we have a program called Rocket Fest, and this is where families have picked up their rocket kits. They've been building it at home for the last couple of weeks, and tomorrow between 9 and 5 we'll be launching 156 rockets between here and down at the field. So this is our most prolific Rocket Fest. We're really looking forward to it. So one of the other things that we do are these Friday night programs. From March to mid-December, we always do a public program of some sort. and it's actually something I really enjoy doing because it's an opportunity for us to perhaps step outside of our own wheelhouse or a particular interest and learn about something new. And so tonight's program is on the history of Planet X. But what's nice about this is that, I mentioned it earlier, we have people watching on the live stream. We have a YouTube channel, Kopernik Observatory, which now has nearly 14,000 subscribers. And what's great about it is every one of our programs is actually recorded. And so a couple weeks ago we had a talk about the Galapagos Islands. We've had a couple of talks on student robotic programs. The Quantum Cosmos from Zoe from the Cornell Astronomy Department, talking about how the smallest things explain the biggest things in the universe. We had to talk about AI. We recently had to talk on the Fermi paradox. And so along with that, with our Friday night programs, but we also do observing sessions as well. And back in March, there was a lunar eclipse, if you recall. Unfortunately, it was it started at 2 in the morning, but yet Jenny was able to stick it out for the entire 5 hours and actually put together a really neat eclipse time lapse. This, by the way, was taken with a C-star telescope, which is a scope that is really an imaging scope, and ultimately basically takes those images and sends them directly to your phone or to your tablet. You can see Jenny had changed the exposure, so now we get to see the blood moon. Then eventually will come out of total eclipse, and then she'll change it back to the exposure, so we get to see the moon as we normally think to see it. So our YouTube channel is great because, again, you'll be able to watch this program at a later time, and we really enjoy it because also it's literally people from around the world will tune in and watch our programs. So if you haven't checked it out, definitely do. All right, so we're going to go back to, let's stop that. Okay. And let's get right to it. Kopernik is very fortunate to have some really dedicated and exciting educators, and one of those is Robert Olaf Seegers. And Olaf really likes to talk about those outer planets. He's done a number of programs for us. Today he's going to talk about something we haven't seen yet, or so we think. So at this point, Olaf, I'm going to turn it back over to you. I'm going to put your slide set up, and let you take it from here.
Okay, so yeah, so I'm really interested in the outer part of the solar system, and what we're going to do today is sort of like more of a historical approach to, how we've actually come across new objects. So it's actually a pretty fascinating history. So yeah, so we'll get started. So when we think about the planets, right? Well, you got to realize people from ancient time. Oops, sorry. Here we go. So people from ancient times, they observed the stars, and at some point they realized, well, there's a handful of stars that are moving amongst the other ones, because the stars, as you know, they're so far away, they're trillions of miles away from us, and they never appear to move in our lifetime, so they're fixed. So those handful of stars were very special, okay? And eventually took the ancient Greeks actually came up with a name for them, planetes. I don't know how to pronounce that, but it's actually a word that means one who wanders. So they realized that Mercury, Venus, Mars, Jupiter, and Saturn all moved in front of those stars and eventually constellations and so forth. So they were special. And pretty much from ancient times to medieval times, the thought was pretty much everything revolved around the Earth, okay, including the sun and so forth. And eventually, our namesake came up with a solution saying, wait, it's actually the sun. We call that a heliocentric view of our solar system. So then we started realizing that, hey, you know what? The Earth goes around the sun along with those other handful of planets that we knew. And pretty much it was just those planets until, by accident, William Herschel and his sister Caroline, they liked to look for comets. Okay, and by the way, they were musicians too. Just kidding. So they liked discovering comets. And one day they thought they found one, but it was behaving a little bit differently. And it turned out they found our seventh planet, Uranus. So that was pretty exciting, and it wasn't controversial or anything. It was just they found it, whatever, and he got credit for it, and they were good to go. So all of a sudden we have 7 planets in the solar system. Oops. And before we go any farther, when you heard me say things like trillions of miles, billions of miles, that's when we start using other ways of measuring things. And in the solar system, we use the term astronomical units. And an astronomical unit is the distance, pretty much the approximate distance between the sun and the Earth. And we call that 1 AU, okay? So when you see that term later on, you'll know what that means, AU, okay? Actually, when we're not going to do this today because we're in our solar system, but beyond our solar system, we use light years. That's how we measure distances, right? So a light year is approximately 6 trillion miles. So those are big, big numbers, right? So anyway, so we'll move on here. And now that you know what an astronomical unit is. So anyway, they're figuring out, they kind of know where these planets are. And they realize there's a pattern. So Titius and Bode, they came up with kind of a formula. So what they did was they said, okay, here's where these planets are positioned. And Bode eventually, he assigned numbers. So here's first of all, here's the equation. So A stands for the semi-major axis, which is a fancy way of saying the astronomical units, how far it is from the sun, and or at least its average. And the X stands for numbers assigned to the planets that we know. So they started with Mercury is 0, Venus is 3, Earth 6. And notice how it doubles, right? Mars 12. And then we'll come to this one in a minute here. Something should be there, and it wasn't. Jupiter was 48, Saturn 96, and Uranus 192. And it all worked very, very well. So it's like, wow, this is pretty cool. And we'll see. Oops. Huh. So that led to a search for that, where you saw those question marks, is missing planet. And in 1800, they formed a group called, it's not a rock band, I promise, it's called the Celestial Police, okay? So the Celestial Police were formed, and their job was to find, 24 of them, their job was to find this missing planet. How come there should be something there? So they started a search, and actually on New Year's Day in 1801, this guy Giuseppe Piazzi, who actually was just in the process of joining the Celestial Police, found it on his own in an observatory in Sicily, and all of a sudden we had another planet, Ceres. And that was great. So all of a sudden there's a lot of excitement, right? Another planet, where it should be too, pretty much, right? Well, that didn't last long, because the next year, one of the police here, Heinrich Olbers, discovers Pallas in 1802, and later on he would discover Vesta in 1807. So all of a sudden they realize, wait, these things are all in the same area, something's not right. And eventually what they realize is these are asteroids, the major asteroids in our main asteroid belt. So the celebration didn't last for too long. Oops, here we go. And you can see where that asteroid belt is if we pull a map here of the solar system here, right? So that's where it is right here. These are actually those other asteroids here. These are the Trojan asteroids. They follow and lead on Jupiter's orbit around the sun. So they share Jupiter's orbit. So Ceres became known as one Ceres as they started numbering them pretty soon after they discovered them. And it is the largest, and actually Ceres is now a dwarf planet. Okay, it's not very big. It's about 600 miles across. I mean, but it's still big enough to maintain a sphere. I guess it's a term called hydrostatic equilibrium, where it can maintain itself enough gravity to make itself a sphere. So it is very planet-like. And actually, I don't want to divert too much here, but Ceres is actually a very interesting place because there is actually water below the surface. So it certainly warrants further investigation. So then, people are starting to study now Uranus, okay, and Neptune has not been discovered yet, but they're realizing that something is slowing Uranus down, and also sometimes Uranus speeds up, and they're figuring it has to be something else out there, because what happens is when they don't know it's Neptune yet, but what happens is when Uranus approaches like kind of this way closer to Neptune, all of a sudden it gets like a boost from Neptune's gravity, and then after it passes Neptune, then it slows down a bit. So it actually, we say, perturbs the orbit whenever it changes. So that led a huge search for the next planet, okay, Planet 8. And it was an amazing story. Actually, I have a book here. I think this is one of the best books I've ever read. I know I've got somebody else here that can attest to that as well. It's called The Neptune File. And I mean, what an exciting story this is. Like, it was like really a race. These people were trying to find this planet, and they kind of knew where it would be. And there was a number of people that were in it. But there was a couple of major players. And in England, we had John Couch Adams, okay? And he was working on it. And of course, he needs the assistance of other, people that work at these observatories, like at Greenwich and wherever. So he has to rely on, basically getting images like star charts and so forth. So it's not like today where you can use a computer to do that. So anyway, unfortunately for him, the other guy that was working on it at the same time, maybe he just started a tiny bit later than him, was Urban Le Verrier. And he had better luck because he predicted Neptune's position within 1 degree. And John Couch Adams, I think, about 2 degrees. So they weren't too far apart. But so once he figured out where it's going to be, he went to the Berlin Observatory. This guy right here, Johann Galle, he actually found it on his first try, which was amazing. So anyway, there was a big meeting. They said, well, Adams deserves credit too. And then it turned out that the guy that was working with him actually missed it. It was there. He missed where Neptune was on that star chart. So anyway, they both get credit for it, Le Verrier and Adams. But anyway, this view you see here of Neptune is not what they saw. I can promise you that this is actually from the Voyager spacecraft, which flew by Neptune in 1989. So it's still a very iconic photo. Oops. Here we go. So basically, Neptune was mathematically discovered. This is 1846. And this photo you see here comes from one of our colleagues, actually, here at Kopernik, by Sasha Zaleski. She did this via the Sleaford Observatory, which actually is near Saskatoon, but somehow she was able to, you're allowed to manipulate the telescope so far online. So it's pretty cool. So this was her photo, and if you can see here, just below, that little dot you see here is Neptune's giant moon, Triton, which actually was discovered like a year or two after Neptune was. All right, so there we go. That's pretty cool. Let's see here. So now we've got a new planet, right, Neptune. And all of a sudden, though, the Bode law does not actually work, because where Neptune is predicted to be is 38 8.8 astronomical units away. Here we go. Right here. Instead, it's much closer. Much closer. So something was not right. You see the other ones, they're all pretty much right on, very close. But so Neptune was not kind of sort of put an end to that, trend. And don't worry about Pluto yet. I promise we'll get to Pluto. So. And here's just kind of a graph. It just kind of shows you. I used the word trend. That's probably where I got that idea. So you can see the blue was the actual distance, and the red was the Thaddeus Bode rule prediction. So meanwhile, remember Leverrier, who discovered, Neptune, predicted exactly where it was going to be. He's like thinking, I need something else to take credit for. So there was this theory that there might be a planet between the Sun and Mercury. So he was trying to work that out where it would be mathematically. And in 1859, they think they find it. Okay, there's something that they see in the telescope, and in their celebration, they've now found this other planet between the Sun and Mercury, and they name it Vulcan. Okay, but as the years go on, nobody can confirm it. Okay, and I should tell you, now we've had what I think was the Pioneer spacecraft, maybe went out there in the 1960s or 70s, and then we had the Mercury Messenger spacecraft, so they would have seen it, right? And by the way, there's a really exciting mission that's going to be going on in Mercury. It's already started, but it's going to be like in orbit around Mercury, I think next year, and it's called Bepi Colombo. It's with the European Space Agency, so that should be really exciting. These are the best pictures you'll ever see of Mercury. So more on that some other time. So that was a bummer. Anyway, so now there still is, beyond, what's beyond that, because scientists, astronomers are looking and saying, you know what, something is still affecting Uranus in a different way, and also Neptune as well. So something must be big enough that's pulling on Neptune, okay, and Uranus additionally. So that started a new search. Another race begins, and it's actually called, it starts to be called Planet X. Percival Lowell, who's very famous for his imaginative description of Mars only a few years earlier, when he interpreted the markings on Mars to be canals, and that was pretty serious because people believed that there were Martians, basically, because it showed there was a civilized, society. So through the 1950s, people really believed there was a good chance there was Martians. They should say too, with Vulcan, people actually thought it probably existed. It wasn't until the 1915, I guess Einstein proved that also mathematically that Vulcan could not exist. So anyway, the search for Planet X starts, and turns out there's an observatory in Arizona called Lowell Observatory, which named after him, and one of his proteges, let's see here, Clyde Tombaugh, actually discovers Pluto in 1930. Okay, so and this is not easy. Okay, what they do is they look at these images from a successive night. So if you'll take a look here, let's try it again, so you can see. And when you see something move in front of our stars, then you know it's in our own solar system. So this was huge news. And in 1930, they figured, I think partly maybe because of the Thaddeus Bode law, but they thought Pluto would be 5 times more massive than Earth. Okay, so Pluto was giant. Okay. Well, then they realized it kind of started to shrink. And by 1955, they said, okay, Pluto is the same mass as Earth. And then in 1968, they realized, oh, it's only 1/5. And now it's like 500th or something like that. So Pluto's been going kind of shrinking ever since its discovery. But anyway, that's how, and this is kind of how we'll see later on here how they find these objects. It wasn't like, you just look in a telescope and there it is, so. Okay, and the great thing about Pluto, though, is we actually did send a spacecraft there. In 2015, it was the New Horizons spacecraft. It was a very exciting moment. Actually, I think we here had something called Pluto Palooza, right? And I had a PowerPoint ready to go, all empty. We were waiting for those first pictures to write because that event was going to be that night. And we waited and waited. And then finally we got our first image of Pluto, and it had that heart on it. And one of the other colleagues that was here, she said, oh, wait, this could be a hoax because it had the heart. So they thought maybe it was just like some sort of, but sure enough, that real heart really does exist. So this was an amazing thing to see, something so far away, so close up, and again, so small as well, right, compared to the other planets. Here we go, sorry. And just some quick facts, because in 1930, Pluto does become our 9th planet. Okay, and it stays that way for 85 years or so. So here it is. You've got our basic, how the size of Pluto. You can look for yourself, the temperature, just like we do for the other planets here, right? And the thing too, its orbit is quite a bit different. That's sort of a tip-off that it's a little bit different than those other planets. When it's its closest point to the sun, we call that perihelion. It's like only 29.7 astronomical units, and its farthest, it's closer to 50 astronomical units. Oops. And Pluto's orbit too is it's inclined. It's 17 degrees off the plane of the solar system. We call that inclination. So it does, and it does come within Neptune's orbit, but they will never ever. Their orbits do not touch at all. And the way Pluto is also locked in with Neptune. This is also very important. For every 3 times Neptune goes around the sun, Pluto goes around exactly 2 times, and they're always at kind of opposite sort of. So they'll never crash into each other or whatever. So even before New Horizons got there, we realized Pluto had 5 moons, and they extraordinarily they orbit basically around the equator of Pluto, just very harmoniously. So that's something in its favor. While a lot of people to this day still think Pluto should be called a regular planet. Here's Pluto's largest moon, Charon. And I know I'm pronouncing it wrong, but Charon, it's half the size of Pluto, which is pretty interesting, pretty unique. And you can see its surface has got a lot of areas where it's a little bit smoother and a lot of cracking, which just says it's a little bit more recent. And another cool thing about these guys, Pluto and Charon, actually they orbit each other in a spot just outside of Pluto here, so it's somewhere like around here. We call it a barosphere. That's the fancy word for it. So basically, Charon and Pluto orbit each other just outside of Pluto's body. Okay, so that's pretty cool. So it's almost like a binary planet. And the New Horizons spacecraft zoomed by, and you can see it all happens within 3 hours. So that's pretty cool. And I guess some of Clyde Tomball's ashes are on that New Horizons spacecraft. So as it continues to venture well beyond Pluto into what we call the Kuiper Belt, which we'll get to in a second. Sure.
How long did it take that New Horizons craft to get there?
Okay, so
I'm thinking 3 hours after.
Yeah, so I think it took. I got to Jupiter, I know, in 2007. I want to say it took off in 2006. And then it took another 8 years from Jupiter to get to Pluto. So that's actually pretty fast. I mean, I think it took the Cassini about the same amount of time to get from Earth to Saturn. So, and
11 years.
oh wow! So when did it take off?
2006.
Okay.
But you gave me the answer, so thank you. Yeah, look it up somewhere.
So,
actually have a signed picture of Plato his signature here at Kopernik.
I'm sure, yeah, I'm sure he never envisioned Pluto to necessarily look like this, but there's a great picture. You can see Pluto's atmosphere, it's nitrogen, but when Pluto is closer to the sun, that atmosphere actually is vaporizes whatever over the surface of Pluto. As it gets farther away from the sun, it actually collapses onto the surface, and then it just kind of repeats that cycle over and over again. So, again, a very interesting world, and even, blue skies over Pluto. Not the same as we have here, obviously, but so then as we go, so then all of a sudden after Pluto, there's, like I said, the Kuiper Belt. There is they start finding other objects, beyond Neptune. Okay, and it's in this Kuiper Belt. Now the Kuiper Belt was theorized and was actually proven true, obviously, by Gerard Kuiper in 1951. He said there'd be a whole swarm of icy bodies beyond Neptune. He was absolutely right. I like this picture here because this picture here, him right here, sorry, it was at my second favorite observatory. So that is in Yerkes Observatory. My brother actually lives only like less than a half hour from it, so I've been able to go there a few times. It's an amazing place. But anyway, my daughter and I actually we're near this desk where he's sitting at. So anyway, just kind of a fun place to go if you're ever in the neighborhood. So it's actually off of Geneva Lake in Wisconsin. It's a town called Williams Bay, which is at the northwest end of the lake. It was actually run by the University of Chicago for many years. Then they pulled out, and then local people actually rescued the observatory, and they're actually using it again. They're actually imaging like trying to get exoplanets and so forth. So they have a huge 40-inch refractor telescope that Hale had designed, and that was the biggest one until the one at Palomar. So 1897. That's how old that is. All right, so anyway, so they're finding these other objects, and one of them, and you'll remember this name here, QB1. Okay, they find that in 1992, and it's I guess it's maybe a couple hundred miles across, but it's something, right? So remember that name QB1, okay? No, it's actually outside the orbit of Neptune. So, and they call these objects now, because they find more and more. They call them trans-Neptunian objects, TNOs. So I'll get to some of these abbreviations here because they're kind of hard to say the words, so it's easier for people to say the abbreviations. So anyway, they're pretty small. All of a sudden, I remember this. I actually heard this in the news. There's one that's eventually called Quaoar. Okay, and that's discovered. And the big thing about this one is that it's about half the size of Pluto, maybe even a little bit more. So all of a sudden we find one that's pretty big. It's going to be round, right? It's going to be a sphere. And it's got a moon. That's pretty exciting, too. You'll see, discovered by Mike Brown. You'll see Mike Brown's name a lot. These guys found a lot of these things you're about to see here, these TNOs. Okay, so their names figure prominently. Now, at this point too, you're going to see like actual objects like this, okay, but also to keep people interested, of course, they hire artists, NASA, whatever. They have artists kind of make a likeness, what they think this world would look like, using the scientific information they get from their observations. So it turns out Quaoar is actually super special because it actually has rings. So it's got a moon and rings, it turns out. Okay, and that actually, I believe the James Webb Telescope figured that out, because what they do is every now and then they'll observe this, this planetoid, whatever, and they'll see it passes in front of a star. That star disappears. It's called an occultation, and all of a sudden that star reappears. Then all of a sudden, the star disappears again, just briefly, and then it appears again. So it's either a moon or it's in this case it's rings. And I guess it depends because it's the same amount of time elapsed, whatever, preceding it and then going on. So anyway, so this is a pretty exciting discovery. So another, and by the way, I'm only going to hit the ones that are really significant. I could keep here all day. I like these dwarf planets. So, but the point is, we're kind of finding things that have a lot of significance as we like find new worlds and so forth. So this one here, I think, was a kind of a big blow to Pluto's status. This one's called Orcus, okay? And an interesting thing about Orcus is it takes about the same exact amount of time to go around the sun as Pluto does, only like 3-year difference. And as you can see, it's kind of hard to see this actually. Well, the next picture I'll show it. But anyway, it's very similar. Let me go ahead and go on to the next one. Here we go. And it's tipped even more on its axis, but you can see it's a very similar elliptical orbit, inclined, and the big key here is because it goes around the sun the same amount of years as Pluto, pretty much. It's because, like Pluto, it goes for every 2 times it goes around the sun. Neptune goes around 3 times. So again, it's locked in with Neptune, just like Pluto is. So now you really got something that really is so much like Pluto. So Pluto is obviously more like this object, right, than the other planets. And then another one, okay, this is Haumea. And Haumea, you're approaching the size of Pluto, just a little bit smaller. It's actually egg-shaped. It's got 2 moons. It also has rings. But the significance about this one here is that for every 7 times it goes around the sun, Neptune goes around 12. So we're really learning now that Neptune really controls a lot of the outer solar system here. Oops. So here are those those abbreviations I promised you. So TNO is anything beyond the orbit of Neptune, trans-Neptunian object. And there's different ones. KBO is a Kuiper Belt object. Most of what you'll see is that. But within the KBOs, there's different versions of those. So remember QB1? Well, here we see a Cubawano, okay? What that means, it's a classical Kuiper Belt object. That means it orbits the sun independently. It's not in any sort of resonance with Neptune at all. So it's independent. There's one I didn't even know of. 2 Tinos. I didn't know this one. I found that out recently. And then, of course, Plutinos, which I mentioned before. Pluto is in a 2-3 resonance with Neptune, and so are a number of other ones, okay, like Orcus, for example. Quaoar actually is also a Cubawano, so it orbits the sun independently. Then the Haumeids, the one I just showed you, there are some of those there have a 7-12 resonance with Neptune. I'm sure there's other ones too, okay. SDO is a scattered disk object. Those are objects that spend most of their time outside of the Kuiper Belt, but they do go inside it. And then beyond that, we have the Oort cloud object. Now, the Oort cloud is actually something that's been theorized that the solar system is surrounded by this, I guess you'd say, membrane of icy bodies. They believe that there could be trillions of comets that come from this Oort cloud. We call them long period comets, right? So we have no proof it's there, but it seems like there's a good chance. And then something's called IOC, inner Oort cloud object. Then with that, there's something called Sednoids, which we'll get to in just a moment. So anyway, a big one too, another planet X, okay, is Eris. Okay, and Eris is when they discovered that, it was basically, they thought at first it was bigger than Pluto, and actually it turns out it's a tiny bit more massive, but not quite as the diameter is a little bit smaller. But so this was planet X, planet 10 actually, for a little bit. So anyway, so Eris is actually one of those scattered disk objects. It turns out it spends a lot of its time outside of the Kuiper Belt. It's got a moon called Dysnomia, and if you forget the name of that moon, that is Dysnomia. So I guess that's what it means. So anyway, so that's Eris. So this was a big step because now you've suddenly got something that's the size of Pluto, and this is when they decide, okay, what are we going to do about Pluto? And they have this. They had this little congress of astronomers, and it was some sort of convention. And I should tell you, though, 2/3 of the people had already left when they decided to vote on it. There was a lot of unhappy people after this. So anyway, so I always tell people, the important thing is that now that Pluto's demoted, but you know what? It's all right. It's still there. It's still a planet, right? And it's got a whole bunch of new friends, right, that are out there in the same area. So you can see then, just like you saw with when Clyde Tombaugh discovered Pluto, here you can see something here going in front. You know it's passing in front of our those stars there. So there we go. And that's obviously on a repeat loop here. But anyway, so so here we are, and then they decide. Well, of course, once they demoted Pluto, then Eris was not going to be our 10th planet either. So anyway, so then they found other objects, and this one here, you'll see this. Here's Eris's orbit. Okay, this green one here. You can see it kind of goes out quite a bit, and another one, kind of a similar orbit. That one, you see the numbers here. It actually becomes the dwarf planet Gong Gong. Okay, so these dwarf planets have very interesting names. They're very, very culturally significant from all parts of the world. And then our next one here is another. This is kind of where we are today. So they discovered Sedna in 2005. Again, a Mike Brown discovery, and he said this is going to be one of the most important discoveries he's ever made. And what it is Sedna's got a very, very special orbit. Okay. Same thing here. You can see it's right there. So obviously it passed in front of these other stars. And there's its orbit. It takes over 11,000 years to make one trip around the sun. Purple's Pluto. Looks like a little trip around the sun, doesn't it, for Pluto compared to Sedna? And this was pretty wild. It's like, how could this be? And like I say, their theory is that part of its orbit, when it's farthest from the sun, we call that aphelion. That is perhaps in that inner Oort cloud that might exist. So, well, then things get interesting because, but before that, this was kind of a fun picture to show here. You can see another view of Sedna's orbit. So there's the planets here, and then you can see the green planets are our outer planets, including Pluto there, right? Here's Sedna. That's quite a trip around the sun, isn't it? Which one's the blue one? Oh. Oh, that's it. I think that's just where I got it. That's sort of the backdrop. Yeah. Unless it's supposed to be the Oort cloud, but anyway, let's see here. All right, so here's a catalog of our dwarf planets. And with the exception of Ceres, they're all TNOs, trans-Neptunian objects. There'll be a quiz for these abbreviations after our presentation here. But anyway, it tells you what kind of object it is. We already talked about what a Plutino is, right? A Haumea, right here. And then Cubawanos, those are the ones that orbit the sun independently. They're not in resonance with Neptune. Scattered disks are ones that spend most of their time outside the Kuiper belt. And then finally, Sedna, which is very detached. And this is where we are today. And all of a sudden, we find other orbits like Sedna. Since Sedna was discovered, some of these go even farther. I wouldn't even be able to pronounce that. So good luck. I don't think what they do is they have these numbers until they're officially named, right? So that's when they're discovered, okay. And what we're finding is this, and there's something very interesting. The way they all kind of share a very similar orbit. Their aphelions are all kind of in the same direction. They all kind of converge here, closer to the sun. Let's see here. We can see that better in the next picture, I think. And this is where they come up with mate. There must be something out there causing this, right? Um, so they think there's another. That's why they theorize there could be a planet 9. That's why these guys are all um, kind of, their orbits are shaped like this. And it's like it's kind of like if you open up a can of Pringles, right? And you pull them apart, and they're all kind of like fanned out like that, right? But then we have a little problem because, well, first of all, they still think there could be a planet 9. Question?
This is about the other slide, but the one with the really long name.
Yeah. Sure. Yep. So the question is, what was the?
Like how far away is? Like how long does that take to go around the?
Gosh, I can find out for you afterward, but it's going to be more than Sedna. It could be like 25,000 years or something like that at least. So, yeah. See, the question is, like, some of these other sednoids have orbits that seem to be even more stretched out farther from the sun at their farthest point than Sedna is. So, 40,000. Okay. So the answer to that was 40,000. So, all right. Thanks. A good question. And now back to so planet 9. Now, up until the search is on, and there's actually an observatory that is going to start, I guess, open for operation in 2 weeks. It's down in South America. It's called the Vera Rubin Observatory. It's a giant reflector telescope high up in the Andes Mountains. I want to say it's like about 8,000 feet up at least, and it's going to specialize looking at into these areas of space where these possible dwarf planets could be. And in fact, one of its main goals is to see if they could find this planet 9. And they kind of know where to look for it, where they think they'll find it. I should go back. I forgot to mention back when Percival Lowell was saying there was a planet beyond Neptune, and he said it would be in the constellation of Libra, and that's actually where they found, by chance, that's where they found Pluto in the constellation. And here's another view. Here's another. This one here in the yellow is another one. It's got a very crazy resonance with Neptune, but here we go. Here's some of the names where you can kind of see, kind of a little map of where this was actually this year. So you can kind of see what area of the solar system they are. Now Sedna here, which is what's got that 11,400 year orbit, what's that?
It's in the close part. That's what
You're right on. And guess what? In the year 2076, it'll be at its closest point to the sun, I guess to us, right? And it'll be only, I want to say, how many? Yeah, it's not too many. I want to say it's going to be around 50 some odd astronomical units away. So there's a possibly you have a spacecraft designed to go there. And one of the reasons why is if Sedna indeed comes from the Oort cloud, we'll really want to know what its surface is like. It'll be really exciting. So there's a move to get something to go out there. So, yeah. So, and this is sort of. I hope this isn't a deal buster. I know, one of my friends and colleagues here sent this article my way. It just came out only, I think, about a week ago or so. And they now found another one of these long orbits, right? But what's wrong with this one? It's in the other direction. So all of a sudden, it doesn't make where they think there could be a planet 9. Well, maybe not. So we'll have to see what happens here. So this is fun, and you guys can certainly come up with your ideas here too. So if it's not Planet X, what could it be that's creating those crazy orbits with those Sedna-like planets? And one is it was random chance, maybe just by chance. The ones, except for that last one, they all happen to be in the same thing. What else?
It could be something extremely far away, but something that, like a black hole that could be extremely far away, but does enough gravity thing that makes these extreme orbits. Yeah.
Right. So that's what he just said was that it could be something like really far, I would say, on the outermost parts of the solar system, or just perhaps just beyond it, maybe something like maybe a black hole, right?
A trillion, like a trillion light years, like just enough to make it so that the sun would still
Yeah. No, that's good. That's kind of one. Yep. Also, past occurrences like maybe a rogue planet went by or a passing star. And don't forget too, we just found out about these places. We know their orbits now, but we don't know how long what their orbits were like. Years ago, like certainly millions of years ago, right? These are new discoveries, right? So we're going to be learning more and more about them. And the other idea is I also had put down, if this Oort cloud exists and it has this many icy objects in it, well, maybe there's enough gravity from those that it could be affecting some of these, and stuff in these other like far out orbits, like Sedna type of places. They're fairly small. It's not like you're tugging on like Neptune or even Mars or anything like that. So I mean, it could possibly. I mean, it's just a thought. Anybody else have any ideas? Okay, could dark matter? That was a possibility. Yeah. So actually, we'll have our microphone go around here if anybody else wants to share this.
Or at least your voice on YouTube. We got a question here. Hold on.
Thanks.
Evidently, there seems to be some kind of bias, like they're not randomly distributed, right?
Yeah.
And they're all kind of leaning this way except that one, right?
Correct.
But it just makes me wonder if maybe they are randomly distributed, and because of gas and other things in the way, dust blocking the view, you can't see.
Could be like
See the stars without trying to associate with that.
Yeah, no, it's possible. I mean, maybe just a particular, maybe openings, where it's location. Yeah. Another question?
could it be like a bunch of different stars that aren't close enough to completely impact
where it's orbiting, but it is doing an impact on its orbit?
Well, the nearest star that we know of today would be, I think, is Proxima Centauri, right? That's too far, but yeah, but it's possible because stars, if something could have been moving, out there. There's, the light you see from an object is a reflection off the sun, right? If something is beyond, in the fringes of our solar system, we're probably not going to see it. There won't be any sort of like reflection from it. So it could be something very dark out there that is doing so. Yeah, I mean, it could be like a star or a planet. Anything else? Or?
Oh, another question. Hold on.
I don't have a comment on this exactly, but with Sedna, you said that like at its closest thing it'll be like 52 or 56 AUs away from the sun. How is
Yeah.
that in relation to like what other planets are around that, like far away?
So let's see here. I got my chart here somewhere. Let's see. Let's see. Pluto at its closest, I think, was 28 or something like that. Was its closest. The other ones are all like those other ones. Kuiper Belt objects seem to be average in like the 40s. Okay. Let me just see because I should know that. Sorry for the pause here. So it's 76. Okay, yeah. And it's going to be in, I think, 2076. Okay. So it's 76 astronomical units, which will be its closest point. So, so right now, though, to answer your question, Sedna is closer to us than Eris is. Okay, so yeah, it'll be coming in kind of some of the same distance as some of those other objects. So I'm sure if it was at its farthest right now, we would never know it would exist because we'd never see any sort of light from it.
How do we detect the Oort cloud, given that it's made of such small objects at very great distance?
Yeah, it's just a theory that my friend's first name, but we'll call him Mr. Ort. Mr. Ort came up with years ago, and they said they thought that like the membrane, like the solar system would be all these like kicked out, early solar system matter got all pushed out to the outside, and it would cover like not. It'd be more like an egg. Like think of it like it's not just like on the plane of the solar system. It'd be like all around, like a big like a oval 3D oval whatever. So we think that's where these comets. There's a reservoir of comets, and they said there could be up to a trillion, trillions of them. So maybe we'll find out. We'll find maybe we'll get some sort of whether it's not the James Webb, but the Vera Rubin. Maybe we'll get more evidence anyway of it possibly existing. So yeah, that's a great question. And real quick, just we talk about distance. It's so hard. There's no way you can show the distance of these objects. Although here at Kopernik, we try to do this on our parking lot on a clear day. So we have chalk, and we have the kids. Well, they'll try to pretty much plug in the numbers, and you can see use exponents here on this screen here. Otherwise, you would never get them all on the same screen. So Saturn, for example, is 10 astronomical units away, and then you can see the effects of the solar wind and at 100, for example, and you can see where that Oort cloud is theorized to be. I mean, these numbers are just gigantic. So it almost seems like when we say Jupiter's in the outer solar system, it almost seems like maybe that shouldn't be because maybe that's central solar system, and then when we get beyond the Kuiper belt, that should be the outer solar system. I'm sure people debate this all the time. So. I think we're just about done here. So.
Got another question here. Hold on.
So, I just thought about it, and an AU, right, the astronomical unit from the Earth to the Sun. So that times pi basically means a year around the Sun, or just 1 year. And how long that line would be for it to move, right?
I don't know.
Circumference is 2 pi r, so pi d. So yeah, that's right.
Yeah, very
So
good.
Pi AU is our orbit.
Yeah.
See, math is useful.
Yeah. I think we found my daughter's math tutor just now. So. So anyway, thanks. Now, the show's not quite over. There's something I'm going to try. I know I threw a lot of information at you, and I'm going to try to kind of sum it all up, but not like this. I'm going to go ahead and turn this off here, free myself here. So I think we have a volunteer. But I need somebody to move those slides. Yeah, our mathematicians are going to kind of do it. You can go up there too if you want to help others. You guys can take turns. All right, so give me just 1 second. I'm going to try something new. You guys are going to help with the PowerPoint. So
All right.
the next slide will.
So you guys take turns on just hitting the right arrow.
So you're going to have to listen to what I sing, okay?
So right now we're on this one. So go ahead.
No, disclaimer, I'm an instrumentalist. I very rarely sing anything, so. So this is basically to sum up on some of what you just heard. One second, sorry. Okay.
in 1930 I had so much hope. I found the moon with a telescope, and overnight she said,
very far, bigger than Earth, palms up like a star. Well, as the decades passed, you rendered me small. My solar system status, it began to fall, but from planet X to number 9, I took my place at the end of the line. Well, I might be small, but at least I'm a sphere with a handful of moons in an atmosphere. My orbit's tipped down a tad askew in a 2-3 resonance with Neptune. They call me a dwarf like I'm some cartoon. I don't know what I am, so I'm feeling blue. Well, things got crazy back in 92. You looked in my neighborhood and found something new, a harmless speck of QB1. Little did I know what had just begun. Well, soon there's Varuna and Quaoar, Sedna, Eris, and a whole bunch more. Orcus, Pamea, and Maki Maki. My time is planet 9, might be history. Well, I might be small, but at least I'm a sphere with a handful of moons and an atmosphere. My orbit's tipped down a tad askew in a 2-3 resonance with Neptune. They call me a dwarf like I'm some cartoon. I don't know what I am, so I'm feeling blue. Well, Kuiper Belt Disney, I am not. My moons aren't bashful, grumpy, or dark, but as Chair and my partner and Hydronix say that I mentioned Koberos and Styx. Well, the New Horizons spacecraft has flown by, leaving you in wonder and surprise with ice, water, mountains, skies of blue, an underground ocean, and a big heart for you. Well, I might be small, but at least I'm a sphere with a handful of moons and an atmosphere. My orbit's tipped down a tad askew in a 2-3 resonance with Neptune. They call me a dwarf like I'm some cartoon. I don't know what I am, so I'm feeling blue. Blue. Thank you.
And one of the things that amazed me in particular is that he knew all those words. I'm thinking like, wow, just, well, anyway, I don't know if there are any other questions, please let us know. I'm just looking at the live stream. Our good friend from Adelaide, Lindsay, is with us. So let's all say hi to Lindsay. There we go. All right. Well, actually, Robert, Olaf, thank you so much again for taking us even further into space than you've done than we've ever gone with you before. And for those that are here, we think we still have something to see. So I would say it's time to head out to the scopes again. If you're here for the first time, the rule is you can't leave until you look through a scope. So please, we have some members of the Kopernik Astronomical Society that'll help you out there. We've even got a scope with a camera mount on it. So if you've got a cell phone, we can get you to. All right. So next week we have one of our Kopernik Astronomical Society members, Art Cassiola, is going to do a talk on beginning telescopes. So if you're interested, if you don't have a telescope or you're looking to maybe upgrade what you have, next week would be a great opportunity to check that out. The week after that will be Jenny doing a talk on summer skies, so at least you can know what to expect this summer. And then the week after that is our annual Great Telescope Dust-Off. So for those of you who've got a telescope, maybe haven't used it in a while, sitting in the basement, the attic, bring it up, bring all the pieces. We'll help put it together for you and show you how to use it. And so that's the next few weeks. thanks again for coming, and hope to see you soon. And by the way, if you're interested in